Welcome to math classes. Let's do some critical questions in matrix and determinants, mainly from BITSAT and JEE PYQs basically. These are all useful for class 11th, 12th, and who are preparing for engineering entrance exams. Let's get into the problems now. Okay, let A, B, C are the coordinates given. Okay, vertices of a triangle ABC. Then the maximum area of the parallelogram 𝐴𝐹𝐷𝐸 formed by vertices DEF on the sides of BC, CA and AB of triangle ABC is. Okay, so if you see, first draw the diagram. That's the main thing. Okay, this is triangle ABC and the DEF are on BC, AB and AC respectively, like this. And we are forming a parallelogram because DEF is parallel to AB and ED is parallel to AC. Okay, so this is more of a geometry problem than determinant or matrices. Okay, that is a small part actually. Okay, but if you see this one, you have to understand, when you form a parallelogram like this, when this parallelogram will have maximum area, when D, E, F are the midpoints of this triangle ABC, sides of the triangle ABC, then only it will form a parallelogram. Okay, and also this parallelogram area is maximum. And obviously, when you this EF, if you join, basically it will make it into four equal triangles, four equal areas of triangles here. Okay, so you should know this one. That means basically this parallelogram is nothing but half of the area of the triangle ABC. That's it. If you know that, then it is very simple. Okay, so that's what I'm trying to do. A DEF are midpoint, so area of parallelogram is half of area of the triangle. And how do you get to area of the triangle? Where 3 points are given, very simple. Determinant method will apply. Half into, okay, 4 comma minus 2 is 1 point, so 4 comma minus 2 1, 1 comma 1 is second point, 1 comma 1 comma 1, 9 comma minus 3 is third point, 9 comma minus 3 1. Okay, so find out determinant whatever you like it actually, row wise, row 1, row 2, row 3 or column wise. Okay, the value is 6. So this is the maximum area of the parallelogram 𝐴𝐹𝐷𝐸, which is half into 6, that is, okay, because this is the area of the triangle. Okay, and I need half of it, so half of that is 3 square units is the area. That's the answer. Okay, next, if f of x equal to a determinant of x cube 2x square plus 1, 1 plus 3x, 3x square plus 2, 2x, x cube plus 6, x cube minus x, 4, x square minus 2, where x belongs to a rational number, then what is the value of 2 f of 0 plus f dash 0? Okay, so this is a very good question I choose actually, because you should understand when you are using determinant and functions how to work on it. Okay, so f of 0 is simple. Okay, you don't need to find out complete determinant and give the definition of f of x. You don't require actually. Okay, so f of 0 is nothing but you replace x with 0. So in the determinant, what you will get is 0 cube, okay, 2 0 square plus 1, 1 plus 3 0 and so on. Okay, now this is a very simple matrix and you can easily find the determinant of this one, right? So f of 0 is nothing but 0 1 1, 2 0 6, 0 4, minus 2. Now definitely there are two zeros in this column, so this is the better way to find the determinant. So minus 2 into, okay, minus 2 minus 4, okay, that is 12. 12 is the f of 0. Okay, now f dash 0, how do you get f dash 0? So here also you don't require complete expansion of the determinant in the polynomial way. Okay, so this is important to note down. When you want to apply determinant to the f of x, when you want to derivation to the determinant f of x, okay, then first do it first row, you find the differentiation. Okay, first row differentiation is x cube is 3x square, 2x square plus 1 is 4x, 1 plus 3x is 3, and second and third rows leave it as it is, plus first and third row you leave it as it is, and second row you keep the differentiation, that is 6x plus 2, 6x, 2 and 3x square. Okay, and plus first two rows as is you keep, and then third row you go 3x square minus 1, 0, 2x. Okay, so this is how you will find the derivation of a determinant. Okay, so now you substitute f dash 0 is what we require, so now you substitute f dash x equal to 0, so f dash 0 you will get, and you choose whichever row you want. Okay, in this one row 1 you can do using row 1 actually determinant, which is 3 into 8. Here it is 0 because one complete column is all zeros. Okay, then minus you can choose by this way. Okay, row 3 you can find the determinant, which is easy, minus 1 into 6. So overall f dash 0 is 18. So what we are looking is 2f0 plus f dash 0, okay, which is nothing but 42. That's the answer. Okay, next.
Struggling with Maths Olympiad or Engineering entrance prep? Let's make it simple. Welcome to Fun with Mathematics, your YouTube hub for mastering IOQM, JEE, and BITSAT with clarity and confidence. For Olympiad aspirants, we dive deep into number theory, geometry, polynomials, recursive functions, and more, with daily practice problems and complete solutions to previous year IOQM papers. And if you're gearing up for JEE or BITSAT, we've got you covered, with full cert classes for 11 and 12, solved exercises, and past year questions across topics like trigonometry, complex numbers, calculus, probability, and statistics. Every concept is broken down with tricks, trades, and visual clarity, so you don't just memorize, you understand. Whether it's sets and relations or the binomial theorem, we simplify the toughest topics and help you build real problem-solving power. Subscribe now at youtube.com/@psk99999 and let's make math your strength.
If A equal to lambda 2, 3, 4, 5, 6, 7, minus 1, 2 is the matrix, and the determinant of A is nothing but is equal to minus 1. So let B is the inverse of adjoint of A, adjoint of A square. Then what is the value of determinant of lambda B plus I? Okay. So first thing is find out, simplify this one. Okay, and find out what is B. Once you get the B, this is very simple. Correct? Because the lambda value we can easily find out. Determinant of A is given. So if I expand this one into determinant form, I will get the lambda value. That is simple. Okay. Only thing is I need to find out B. Correct? So note down these formulae. Adjoint of A square is nothing but adjoint of A whole square. And remember that definition of inverse. Okay, determinant of A into A times A inverse is nothing but adjoint of A, and determinant of AI equal to A into adjoint of A. Okay, these two are same basically. I just placed here and there. Okay, so now let's go and simplify this one. Adjoint of A, adjoint of A square. Okay, this one I will write it as adjoint of A into adjoint of A whole square. Okay, now A into adjoint of A into adjoint of A is nothing but determinant of AI. Correct. So if I put that here, I am getting adjoint of determinant of A into adjoint of A. This is what remains. Okay. Now simplify this further. Okay. Determinant of A, adjoint of A is nothing but, okay, you can get determinant of A into A inverse. So if I substitute adjoint of determinant of A square into A inverse, this is nothing but adjoint of A inverse. Okay. Because determinant of A is given as minus 1. So I am replacing. This is nothing but adjoint of minus 1. Okay. Now all I need is inverse of this one, because B is inverse of this value. Correct. So B is equal to adjoint of A inverse whole inverse. Okay, which is nothing but determinant of adjoint of it's given here, right? Adjoint of A is determinant of A into A inverse. So here it will become adjoint of A inverse is nothing but determinant of A inverse into A inverse whole inverse, which is A whole inverse. Okay. So what I am left with is, I know determinant of A inverse also minus 1, because the determinant of A is minus 1. Okay, so this is nothing but minus A inverse. Okay, B is nothing but minus A inverse. Now I need to find out lambda. Lambda is very simple. Determinant of A is, if I expand this, 16 lambda plus 68 minus 117, which is equal to minus 1. From this I will get my lambda value, which is 3. Okay, now lambda B plus I determinant, right, is nothing but, this is nothing but, B is nothing but minus A inverse. Correct. So I will make it I first, minus 3 in A inverse. Okay. Now I multiply both numerator and denominator with determinant A. Just to simplify, I can actually find out A inverse and get the answer. Okay. But this is simple. Okay. Determinant of A, if I multiply both numerator and denominator, what I will get is, if I take this inside, okay, this is nothing but 3i. Okay, determinant of A is minus 1. So this will become A minus 3i. 3i. A into A inverse will become A, I will take inside. A into I is A. A into 3 A inverse is nothing but 3i. Okay, so this is determinant of 3 minus A minus 3i divided by determinant of A. Okay, now this is simple. Correct. So 3 A minus 3i divided by determinant of A is nothing but minus 1. Okay, this is minus 1 into 3 minus A is nothing but this 0, 2, 3, 4, 2, 6, 7, minus 1, minus 1. I can easily find out determinant of this one, which is nothing but overall this is 38. Okay, so my lambda plus I is nothing but, determinant of lambda plus I is nothing but 38. That's the answer. Okay, just a confusion because you need to clearly do this. I have seen these kind of problems, many came in JEE. Okay, so every year you are finding one of such problem where adjoint of A, determinant of A, all this mixture they are giving. So do it carefully. If you solve few problems, you will be good in. Next. Okay, let S equal to M belongs to Z, real numbers. Okay, where A to the power of M square plus A to the power of M equal to 3i minus a to the power of minus 6, where A is a matrix 2, minus 1, 1, 0. Okay. Then what is the number of elements in set S? Okay. So first thing is, this is one important matrix which you can remember actually. Okay. Are all such problems wherever you are dealing with power, first find out whether there is any relation between powers and the elements. Okay. So that is the most important step you will take. Okay. So this is A. My A square is nothing but 3 minus 2, 2 minus 1, which is exactly plus 1, minus 1, plus 1, okay, plus 1, right? And A cube is nothing but, okay, A to the power of 1 here, okay, I am getting 2 ones, okay, and 2 and 0, correct? And A square is nothing but, both 2's are here and 3 and 1. A cube is nothing but 3 and minus 3 are here in one diagonal, and the main diagonal is 4 and minus 2. So there is a relation. Okay, with this we can easily tell what is my a to the power of minus 6, a to the power of m square, a to the power of m. Okay, so my a to the power of m is nothing but m plus 1 minus m minus of m minus 1. Okay, and my a to the power of m square is nothing but m square plus 1 minus m square minus of m square minus 1. So a to the power of minus 6 is simple. Okay, minus 6 plus 1, which is minus 5. Okay, minus of minus 6, which is 6. Okay, minus 6, and then minus of minus 6 minus 1, which is 7. Okay, this is my e to the power of minus 6. Now all I need is this condition I have to check, correct? So this is the condition given. So that condition is nothing but m square plus m plus 2 minus m square minus m square plus m minus of m square plus m minus 2. Okay, so now if I equate this one, this is very simple actually. This side I'll get 8 minus 6, 6 minus 4. So I can take any of the equation and solve it. Okay, and make sure that the values are satisfied by all these elements. Okay, so I am taking the first one, m square plus m plus 2 equal to 6, or m square plus m equal to minus 6 equal to 0. So if I solve this, I get two values basically, m equal to minus 3 comma 2, which means two values are possible in the set S. S set has minus 3 comma 2. So number of elements in set is S is 2. That's the answer. Okay, thank you. Let M denote the set of all real matrices of order 3 by 3, and let S equal to set S. Set S is defined as minus 3, minus 2, minus 1, 1 comma 2. These are the elements of the set. Okay. Let S1 defined as A equal to matrix A comma J, which belongs to M, that is 3 by 3. That means, okay, such that A is equal to A transpose. For all Aij belongs to S. Okay, Aij belongs to S. Element is from this set, and condition is A equal to A transpose. Okay. Now, second, S2 is defined as same. Okay, a matrix A which belongs to M, that is 3 by 3, and condition is A is equal to minus A transpose. Okay, and elements in each of this matrix is again belongs to this set S. S3 is nothing but A equal to A is a matrix belongs to 3 by 3 order, such that A11 plus A22 plus A33 equal to 0. That means this is the diagonal elements of a 3 by 3 matrix, correct? This is equal to 0 and elements belongs to this set only. Okay, then what? Question is, if number of elements in S1 union S2 union S3 is equal to 125 alpha, then what is the value of alpha? They're not directly asking number of elements in this union. They are asking if it is 125 alpha, what is the alpha? That is, okay. So first thing is write the matrix here first. Okay, elements. Then you will understand this problem very easily. Okay. So this is how the 3 by 3 matrix looks like. A11, A12, A13, A21, A22, A23, A31, A32, A33. Diagonal elements are A11, A22, and A33. So for transpose, this is very, very important. Correct. So first thing is, let's check for the S1. That is case 1. Number of elements in S1. How many? Okay. So condition given is A equal to A transpose. So if A equal to A transpose, that means A1, A2, A3 can be anything. Okay, because A and A transpose will have same diagonal elements, correct? Only thing is A12 equal to A21, A13 equal to A31, A23 equal to A32, correct? So which means these are my conditions, and A11, A22, A33 can be any of these 5 elements. Each one can be any of these 5 elements. So what is how many options we have for the diagonal elements? 5 into 5 into 5. Okay, which is 5 cube for diagonal elements. Other elements, even though I have 6 elements, other elements, but 2 of them are same. They are pairs are same basically, which means ultimately I have only 3 elements I have to choose, and each one has 5 options. Correct. So again another 5 cube. So total choices are number of elements in S1 is 5 cube into 5 cube, which is 5 to the power of 6. This is my number of elements in S1. Now case 2, number of elements in S2, which is A condition is A equal to minus A transpose. For minus A transpose, if A equal to minus A transpose, that means the diagonal elements should be same in both, means only 0 is the only option. Diagonal elements have to be 0. But in this case, there is no 0 in set S. Correct? There is no 0. That means case 2, our number of elements in S2 is 0. Okay? Total choices or number of elements in S2 is 0. Case 3. Here condition is A11 plus A22 plus A33 is equal to 0. That means sum of diagonal elements is 0. Okay, so you have to find out cases from this one where sum of these 3 can be 0, and those 3 can be adjusted in any way. Correct. So let's find out first this one. A11, A22, A33 can be either 1, 2, minus 3, minus 1, minus 1, minus 2. Okay, so this is basically minus 1 is repeated. Okay, or 1 comma 1 comma minus 2, and there is no other option possible out of this. Okay, now this one can be 3 factorial ways. I can 3 elements can choose any of the 3 elements in 3 factorial ways. Correct. Second one is there is a repetition, so 3 factorial by 2 factorial. Third one, there is a repetition, so 3 factorial by 2 factorial. Okay, so the total diagonal element options is nothing but 12. And what about the other elements? Other elements, there is no condition given. So other 6 elements can be anything. So each one has 5 options. So other elements can be 5 into 5 into 5 into 5 into 5, which is 5 to the power of 6. So total choices in number of elements in set 3 are 12 into 5 to the power of 6. Okay, now you have these 3 values. Now it is a problem of simple set theory. Set theory says, okay, for this you need intersection values. So number of elements in S1 and S2 is nothing but 0, because S2 is 0, so it will be 0. Number of elements in S1 and S3, here you have 5 to the power of 6 values, here you have 12 into 5 to the power of 6, but out of that only this 12 and this 5 to the power of 6 values where they are equal, right? Equal options only we should consider. Okay, so 12 into 5 to the power of 6. Number of elements in S2 intersection S3 is nothing but 0, because S2 is 0. Number of elements in S1, S2 and S3 is also 0, because you have a 0 here. Correct. Now once you know this one, number of elements in S1 union S2 union S3 is nothing but, this is the set theory, right? Says number of elements in S1, number of elements in S2 plus S3 minus S1 intersection S2 minus S1 intersection S3 minus S2 intersection S3 plus S1 intersection S2 intersection S3, right? You have all the values here, so just substitute them. What you will get is 125 into this value, okay, which is 13 into 125 minus 12 equal to 125 alpha. So alpha is nothing but 13 into 125 minus 12, that is 1613. This is the answer. Okay, hope you understand how to solve this problem. Problem looks very complex and lengthy, but it is lengthy, but it's not complex. Okay, next. Yeah, let A be a 3 by 3 matrix such that X transpose into A X equal to 0 for all non-zero 3 by 1 matrices. Okay, X equal to XYZ 3 by 1 matrix, A equal to A into 111 element 3 by 1 matrix is nothing but 145, A into 121 equal to 04 minus 8. Okay, now determinant of adjoint of 2 times A plus I equal to 2 to the power of alpha 3 to the power of beta into 5 to the power of gamma. Then what is the value of alpha square plus beta square plus gamma square? Yeah, this is a lengthy problem, but you can solve it easily. Okay, so first thing is let's call A equal to A B C D E F G H I. This is simple. Now A into X, this is nothing but AX plus BY plus ZZ, DX plus EY plus FZ, ZX plus HY plus IZ. correct? Now X transpose into AX. X transpose is nothing but XYZ in a row, which is in columns here, which is in rows here, it will become into column. Now if you multiply this, what you will get is, okay, AX square, carefully do, A into X square, okay, DXY and GXZ. Okay, so now make sure that all elements are common elements are taken care. So I wrote it here, AX square plus EY square plus IZ square. This is unique. And then wherever you have XY term, B plus D into XY, C plus Z into XZ, F plus H into YZ, which is equal to 0. Okay, because it is given that this is 0. Correct? Now, which means you can actually find out there is no X square term, there is no Y square term, there is no Z square term. So A equal to E equal to I equal to 0. B plus D should be equal to 0, which means B equal to minus D, C equal to minus D, F equal to minus H. Once you know this one, this matrix basically has repetitions. One is diagonal elements are zeros and other things are repetitive, right? And with the negative value. So the matrix actually looks something like this: 0 BC, minus B 0 F, minus C minus F 0. Okay, A is a skew symmetric matrix, if you see, correct? Because A equal to A transpose you are getting. A equal to minus A transpose. Okay, so which means, okay, now A into 111 is nothing but this one, which is nothing but B plus C, F minus B into minus C minus F, which is 145. These are the three sets of equations I got actually. And the second one, from this second one, A into 121 equal to 0, 4, minus 8. From this one, I get another set of three equations, which is 2B plus C equal to 0, F minus B equal to 4, minus C minus 2F equal to minus 8. Now I have 6 equations. Easily I can solve the B, C and F, B, C and F. Okay. So from these 6 equations, B equal to minus 1, C equal to 2 and F equal to 3. Now I got my matrix. Okay. Now matrix is here. Now I need to find out this value. Correct. So let's do the second part. This is my matrix. Okay. This is the matrix. 2 times A plus I is nothing but this matrix. Now adjoint of this one and a determinant. Okay. Determinant of A I found out here. Okay. This is 120. Now adjoint of M is nothing but M square. Okay. Determinant of adjoint of M is equal to determinant of M whole square. So if this is M, then adjoint of this one is, sir, actually this is not determinant of A, this is determinant of this whole 2 times A plus I. Okay, sorry. Okay, this is determinant of 2 times A plus I. Now the determinant of adjoint of 2 times A plus I is nothing but 120 square. Correct, because this is 120, this will become 120 square, which is, if I write it in prime factor way, 2 cube into 3 into 5 into whole square, which is 2 to the power of 6 into 3 square into 5 square. This is my 2 to the power of alpha into 3 to the power of beta into 5 to the power of gamma. So my alpha is 6, beta is 2, gamma is 2. Correct. So my alpha square plus beta square plus gamma square is 44. This is the answer. Okay. Hope you understood this variety of problems which are coming in determinant. Okay. Also keep checking my charts which I am making for determinants. Okay. All the PYQs, most of them are PYQs, but if I find any other interesting problem, I will definitely add those also. Okay. Keep doing maths. I'll come up with more videos. Thank you.